In this video, we're going to look at FreeCAD's global and local coordinate systems. Stick around. Hi, I'm Geoff, and I'm here to help you learn FreeCAD so you can design the things that you've imagined. If you're new here, don't forget to hit the subscribe button so you can stay up to date with my videos. FreeCAD has two coordinate systems that work together, but sometimes they seem a little bit strange. I got asked a question about this a while ago, and to be honest, I bollocksed up the answer. So let's have a look at them. FreeCAD has a global coordinate system which defines the whole model. It also has a local coordinate system which is based on the planes used in the part design workbench. I'm going to give you an overview of the two coordinate systems and give you a demonstration of how you can use planes and the local coordinate system to override or adjust the attachment point of the plane. If you'd like to support the channel, you could buy me a coffee through the link in the description below. Now let's get started. I'm using FreeCAD version 0.19 for this demonstration, and I'm running it on Ubuntu Linux version 20.04 LTS. As a general rule, we don't use absolute coordinates in FreeCAD. We would normally design a part that was, say, 1 meter long, 250 mil wide and 50 mil high, rather than drawing a box starting at 000 and going to 1000,00, etc, etc. It's just easier that way. In a typical design session, we would use both the global and the local coordinate systems without really paying too much attention to either of them. FreeCAD's global coordinate system is represented by a cube with its origin at the dead center of the cube. Typically speaking, the x-axis moves left and right horizontally. The z-axis moves up and down vertically. And if we switch to isometric view, you can see that the y-axis moves backwards and forwards in and out of the screen. This coordinate system allows you to draw a line from any point to any point in 3D space, assuming that your software supports it, which, as far as I can see, FreeCAD doesn't. Early on in my career, I used a 3D CAD system that did allow you to do that, and whilst it gave you quite a bit of freedom, it also made things a little bit more difficult. And I think I prefer the FreeCAD method of doing things where you work with objects, not coordinate systems. I'll concentrate mostly on FreeCAD's part design workbench in this video. FreeCAD's part design workbench uses a plane-based system for defining geometry. The planes are Cartesian planes, which we learned about at school. They are a two-dimensional Cartesian plane where the x-axis is horizontal and the y-axis is vertical. The plane is anchored in 3D space with an attachment point. This may be confusing to some, so let me step out of FreeCAD for a moment and explain further. One way to think about this is to consider a drawing on a piece of graph paper. Here's one I produced earlier. As you can see, it's just a simple sketch. The origin point is about here. And as I move it around my environment, see the origin point moves, but everything else stays relative to the origin point. Now, consider this block of wood is the physical representation of that sketch. The origin point is still down here. Move that around. Again, you can see that the origin point moves, but everything else is relative to it. And this is how planes work in FreeCAD's part design workbench. FreeCAD has three basic planes, but you can create other planes if you need them. The three planes are the XY plane, the XZ plane, and the YZ plane. Each of these planes passes through the origin of the model. I've recreated the paper example as a sketch to further explain how the planes work. You can see that the sketch looks just like the one on the paper, and if I extrude it out using the pad tool, it'll look like a block of wood. The plane that I used to create the sketch passes through the origin of the model. But what happens if I want to create a plane that doesn't pass through the origin? Well, the easiest way to do that is to select a face on the existing model and then create a datum plane. This creates a plane that is parallel to the original plane, but is also offset from it. So if I turn off the pad and turn on the origin, should be able to see and rotate it that this is the original plane and this is the datum plane. You can see there is an offset between them. Now, when you select the datum plane and create a sketch on top of it, you'll see that the items in the sketch are also offset from the original plane. You need to be careful when you use this method because you run the risk of the topological naming problem raising its ugly head. There is a link up above to my video which explains the topological naming problem. Now let's have a quick look at local coordinate systems before we try and move a plane in the global coordinate system using a local coordinate system. As its name suggests, a local coordinate system is specific to a feature in the model. Two examples of this are sketches and datum planes. I'm going to use the datum plane that I created earlier just to illustrate the principles of the local coordinate system. The local coordinate system works the same regardless of which plane or view that you are working with. The x coordinates are horizontal across the bottom of the datum plane, and the y coordinates are vertical up the screen. The z coordinates go in and out of the screen, so it's much like using a piece of graph paper. You can see this behavior whenever you are editing a sketch. Your sketch is in 2 dimensions. You can place your sketch elements in the x and y coordinates, but you can't change the z coordinates. All geometry that you place in the sketch is relative to the sketch's origin point, or 0, 0, regardless of where the sketch actually lies within the 3D coordinate space. FreeCAD automatically translates the coordinates in the sketch to the global coordinate system so that the model is created correctly. After all that waffle, let's have a look at how this actually works. Each feature in a FreeCAD model has a placement point. Some features only have placement points, but those features that are defined in the part design workbench also have an attachment point. So if we have a look at this cube, which was created in the part workbench, you can see that in the data section, it has a placement point, which in this case is 0, 0 being the origin of the model itself. If we click on the pad and then open the pad sketch, you'll see that the sketch has a placement point and it also has an attachment point. The placement point is the actual origin point of the feature in the 3D coordinate space. The attachment point is the offset from the placement point in the global space of the plane in which the part design workbench feature was created. Now that's a bit of a mouthful, so let's have a bit of a look at it. So what I'm going to do is hide the cube, turn on the pad, get it to screen, and then also turn on the datum plane. Now you can see, as I said before, in the sketch of the pad, it's got an attachment point and a placement point, and that's the same as with the datum plane. Now what I'm going to do is I'm going to adjust the attachment point of the datum plane so I can move it back or forward, up or down, left or right in the global coordinate space by changing the plane's local coordinates. Remember that the placement point is in the global space and the attachment point is in the local coordinate space. Also remembering that in the local coordinate space, using this datum plane as an example, the x and y coordinates increase and decrease along this axis at the bottom of the plane. The y coordinates increase or decrease along this axis on the plane, and the z axis increases and decreases forwards and back of the plane. So if I want to move the plane closer to me or forward in the model, I click on the Z coordinate in the attachment point, and then I can simply move it forward or backwards. When I do that, anything attached to that plane will also go with it. So if I turn on the sketch, you'll see, and then go back to the datum plane and manipulate the Z coordinate. And once I enter it, you'll see the sketch followed as well. So do it again. So it leaves the sketch behind until such time as we confirm that that's where we want it, and the sketch comes forward. Similarly, if I push it backwards, the sketch goes with it. You might be saying to yourself, hang on Geoff, the axis down the bottom here says that Y is going in and out of the screen. Well, that's because that is showing the global coordinate system, not the local coordinate system. It took me a little bit of a while to wrap my head around that one because I kept doing dumb things. Getting back to it, if I wanted to move it up the screen, I would manipulate the Y coordinate, as you can see here. and the sketch follows. Similarly, if I want to move it left or right, I just manipulate the X coordinate and it goes with it. Features created using the part workbench and the draft workbench are not attached to planes, so they are called unattached features. When you create a datum plane in the part design workbench, you can either make it attached or unattached. So let's have a look at that for a moment. To demonstrate that, I will create another datum plane and I will simply accept the default coordinates without attaching it to anything. Now, when I have a look at the datum plane itself, you can see that, like the cube, it only has a placement point, which I can adjust in the global space. But if I was to attach the datum plane to a surface on a feature, you'll see that the datum plane has placement point and an attachment point. This shows that it's an attached object. Now, the only way you can change the placement of the datum plane is through its attachment point. And this is where the local coordinate system comes into play. In this particular instance, because of the orientation of the plane, the z-axis is vertical in the same way as the global coordinate system. But if we have a look at the other datum plane, activate that, its local coordinate system is such that the Z is going in and out of the screen, like so. It's really important that you understand the difference between the local and the coordinate system if you are planning on using planes and manipulating the location of the planes. Because once a plane is attached to an existing feature, you need to change the attachment point in the local coordinate space. But if you don't attach a plane to an existing feature, you have to do it in the global coordinate space. Can do your head in a little bit, as it did for me for a little while, but now that I understand it, it makes sense, and I find that it works really well, but your mileage may vary. Well, I hope you enjoyed the video. If you did, please click the like button. If you're new here, subscribe to the channel and click the notification bell so you stay up to date with my videos. I'm grateful for all the support that I've received on this channel, and if you'd like to help me with my work, please consider buying me a cup of coffee through the link in the description below. Thanks for watching, and we'll see you in the next one.